This is me. I'm Phoenix Ferry. This is like my normal day-to-day. I'm most comfortable in a hoodie and, with coffee. So they've let me out of the lab. God knows what's going to happen. I also am a lecturer at Goldsmiths University in computing, where I teach on an MA that I created in independent games and playable experience design. So if you want to study and do a master's in building weird playable experiences, come find me after and I'll talk to you. Okay, so let's talk about hardware games, or how to create ridiculous problems for yourself. So I want to take a second, and this is like a memento mori to everything that we're doing here right now, right? We're in this giant factory, and everything that y'all think is so hip right now is gonna have this in like 30 or 40 years, right? And it's a moment, like, we're now seeing manufacturing returning to our cultures and to our societies, and we're in this giant, I can't not see the irony of this, like this giant tome of an old factory. Okay, so today I'm going to talk about experience, embodiment, and ecology. So what's my experience? I grew up pretty much like we all did on video games. So Pac-Man is kind of my lineage and my background. I learned to program very, very young. Making video games was something I always wanted to do. And I was playing games online back in the super, super late 80s, early 90s, which dates me age-wise. And this is the very first computer I actually went on the internet with. It's a VT100. If anyone here can remember this is a VAX terminal, and it's in Unix. I think that there's one other Unix developer in the room over there. She's on her phone. She doesn't notice. That's fine. Move on. But Bianca told me today, she's not even going to look up. Okay, fine. Okay, anyway, so Unix design, and I was thinking about how to make video games, and that ended up with me working in Silicon Valley in the early 90s. And I ended up hurting myself quite badly, and later in life I ended up getting diagnosed with a disease in my connective tissue. And I've sort of came to this realization that my body was not going to allow me to use interfaces the way that normal people use interfaces. So I had to start really rethinking interface design. And I began to think about things I could do with my body easily. And motion became this kind of interaction I was really interested in trying to figure out how to use to create interface design. So I started seeing my body as a technological material instead of something that I wasn't, part of anymore. And I started thinking, well, what is it that I can do? Because using computers is not actually really great for me. I get really bad headaches. I get kind of sick and nauseous pretty easily. And mice and keyboards are not my jam. So what can I create with? So this led me to kind of accidentally developing a TRANS-FORMALIST approach to play. Because I had to take this really unstructured and really ridiculous route about designing and creating interactive systems. So this was the first project that once I got my body back together enough after I originally got, hurt, that I did. It was called Black Swan, and this was a band. And I decided, what would it be like if I didn't have to use a computer at all to make music? What would that process look like? What would it look like if I didn't need a computer to do video? So I worked with this early technology called the Kinect, which some of you may know. It was better than a camera, which was what I was trying to use before, especially at night in nightclubs. And I started thinking, how do I train a system? So what I stumbled on really quite early in the game was machine learning. And that allowed me to design for my abilities. And if you guys are new to machine learning or you've not done it yet, I really encourage you to kind of take a minute and understand what a recurrent neural network is, because it will allow you to customize your interfaces in any way you see fit. And I think that that's going to really change the future of interface design. So this was a original system. You can see this screenshot in a very embarrassing YouTube video. My friend came over to my house and she was like, "What are you doing?" And I was like, I'm using this machine learning algorithm. She's like, "We got to film this." I'm like, "I'm in my pajamas." And one thing leads to another. But this is a screenshot of a machine learning system I built that would change the animation based on how I moved my arm, which was really fun. And so the way that a recurrent neural network works is kind of by estimation. So particularly with computer vision, this is really, really useful. So you're not going to be able to strike a pose. I mean, we're not all Madonna, right? We're not going to be able to vogue precisely. So if you know you're going to be able to move this way, you can kind of say, okay, I want to get close to this, and I'm going to get close to this, and I'm going to get close to, maybe something like this. And these are slides from my friend Rebecca Febrink's presentation on her software I was using at the time. You should all check it out. It's called Wekinator. If you're an artist in here, she has done a great deal of engineering to make it possible for people like us to use machine learning. And basically what this algorithm does, this neural network does, is it looks at a gesture you make and tries to guess which one of these 3 buckets to put it in. And then it'll give you a rating on like a score of 0 to 1 of how close you are to this bucket or that bucket. And what that allows you to do is build really flexible interfaces, because you can be like, okay, I'm going to make one thing, and I apologize for this bastardization of a neural network. It's so you guys can understand it easy. But basically, I'm going to raise my arms, and then I'm going to, play. My friend played cello, and she was in my band. She's going to bow her cello really lightly. And that's going to result in, graphic changes and color changes and tempo changes. And if you train a really, fun environment with that, with, 20 of these, all of a sudden what you have is, a collaborative partner. And you've got a system that's just going to respond to you in unexpected and fun ways. It's kind of a new way of creating improv or experimentation. And I really loved it. So then I thought to myself, okay, what would it look like if I took everything I learned and built a collaborative social world building and music creation tool for other people instead of just myself? So that led to this ridiculous quest I have been on now for 8 years about creating collaborative social music making tools. So this is Night Games, which I have no excuse for how long this project went on. It had multiple iterations. But my original prototype was, okay, I'm going to take everything I was doing and stick it on PlayStation Moves and dress my friends up in costumes and hand that control over to children, which is an experiment. It's really cool. I saw kids do things like call and response, rap battles, all kinds of ridiculous things that only children would do when you give them sound. And I used machine learning to do things like, if I had a snare drum, if you turned it, all of a sudden the controller would speed up or slow down how quickly that snare drum would happen. And I took my very first crack at this and not telling anyone what the gestures in the controllers were. They just had sounds, and I figured if it was a big bass beat, people would just be like, dunk, because that's what people do. So I tried to emulate natural playing ability. So the best thing that could possibly ever happen in this scenario is that a drum corps rolls up, because these ladies were amazing. I couldn't understand how they were making such good music together so quickly. Can we get louder audio on this? Yeah. But they did a really good job, and it's interesting in the people in the back, they have no idea because they've never played music together before. But these women in the front clearly know how to play together because they were just like, okay, we got this. And it was interesting for me to see that interaction. And that's when I started thinking, how could play and games be ecologies? How could they be worlds that we could let people inhabit with their bodies? Versus games as economy. So if any of you here are video game players, you should be really well versed with economy systems. And those are systems that let you buy things or, kind of build up a collected wealth. And that's all great and good, but what happens if you just strip all that away, right? And you start seeing games as this possibility space where the rules are created by the play in response to the world. And you build this kind of ecological approach to play where the systems can learn to adapt over time. And this allows players to kind of make up rules on the fly, which is actually really, really fun. And the play experience can unfold around them based on the weird things they come up with. This should sound really familiar to everyone in this room. I think it's called childhood, right? And it creates this empowered, agency-driven environment where people feel really comfortable just making stuff up and playing around. So Night Games evolved, and I decided to split that control system out into this giant, maybe foolhardily errand of a geodesic dome and build a tree and some clouds. And the idea was the clouds, when you would sing back to you, and the dome, when you touched it, would trigger sound, and the tree would be interactive, all light up. And I thought quite a lot about the pitch and the like scale of where the sounds would sit in space. So I put the stars at the high end of the spectrum, and I put the tree kind of towards the bottom, and I tried to think about like the physical space and the sonic gradient that should happen, because things up high should be high, right? So I designed some clouds, and then I got in my head that it'd be a good idea to build a giant geodesic dome. Don't do this. Just don't do this. It's a disaster. I managed to recruit a lot of people to fold a lot of paper clouds. And then I painted the sensors on the inside of the dome. So you can't really see them, but this is the sensor design. So inside, a bunch of people could stand or sit, and you could trigger sounds. This was an enclosure for a rock, because I had this idea that you could kick a rock around like a soccer ball. This was a really heavily thought out idea, because I wanted the enclosure and all the electronics to be able to be kicked around. So I made them really strong and really sturdy, but I really messed up the design, and people started throwing this sharp-edged object at each other's faces. It was not pretty. So maybe no. So then the next thing I did was okay, I'm going to paint this tree. I like this because my cat's in the photo, and the guy who created Atari's in the background, because I watch video game documentaries when I make stuff. This is my friend Adele Lynn. She helped me on this project. She's amazing. She's a machine learning researcher at Intel. She's rad. Probably one of my best friends in the world. This is a guy who helped us out. This is what it looked like when we were done, which was really close to kind of the original prototype. This is the sensors on the inside. So something very bad happened to me here, and I'm just going to warn everybody in the room. If you work with conductive paint outside, seal that nonsense. Because I didn't, and the water and the moisture really impacted my sensors. So if you get the itch to play with conductive paint, do a lot of testing ahead of time. But here's what it looks like when people are playing it. I had to hack around it, as you can see, with tape. It's kind of embarrassing. So you can kind of hear the music changing as she's putting her hand on the sensors. So yeah, that was it. So anyway, so here's THRUM. I have a ton of crazy projects. That's one. So THRUM was this kind of lifelong obsession I've had with vibration and bees. So I thought it'd be really cool to see if people could find and follow vibration cues in the dark blind. And I decided to develop a giant haptic floor. Maybe another foolhardy errand. But all these holes hold haptic motors. So these giant kind of hexagonal structures try and emulate how bees communicate with each other, because there's this thing called the waggle dance, where they kind of shake their wings and move around. And what they tell each other is the position to the resources, right? So I wanted to get people to play together and listen to the sound cues that the motors were making in the wood, and it actually makes this roar. Because if you think about bees, they can't see inside their hive. It's dark, right? And the whole hive is just vibrating. What's that like as a reality model? So I tried to give people that experience. So I put them, when they played, in some of the versions, obviously it's useless to show photos of this version because I can't take them. But I put them in the dark and then put them in black glasses. So it was very hard for them to see. I worked on this project with Heather Kelly for the original design. We holed up in a hotel or in Chicago and came up with some design ideas. But this is the idea, is the bees communicate via sound waves, the direction that you should go in to collect food resources. So basically, this is a process that requires collaboration, and I think we need more of that as people. So this is the haptic grid. I CNC'd it, and each one of those holes holds a precision. If anyone wants to talk about haptics with me afterwards, come find me. It's a precision micro drive haptic motor, 3 volts. This is what circuit board looked like. I'll talk nerd with you later. But this was my first test, and I wanted to see if it was possible for people to kind of feel around to find these cues. And turned out it pretty much was, which was kind of fun. This kid was my favorite player. He was just super enthralled by the fact that the floor vibrated. And then these are the goals. So these goalposts represented the nectar that people needed to find in the dark. So this is what the system looks like with lights on, and with it off, well, it's just black. Anyway, so from there I was like, okay, I still want to make music. I want people to collaborate. I want them to touch each other. I want them to communicate via touch cues. What else could I work on? So I started developing this project called, what was at the time, BabyBot. So I had this idea, and this was maybe another foolhardy errand, to make a modular synthesizer that kids could control together by patching cables. As you can imagine, my player tests were not very good, but I managed to create something that looked kind of like this. That's a synthesizer with a step sequencer attached to it, and you patch it together using this really old control methodology called control voltage. And kids had fun with it and stuff, but once I put too many of these modules together, it just meant kids were falling over cables. So I kind of gave up on that idea, and I was going to throw the whole project out and just keep working on THRUM, but I had made the mistake of promising a curator a room full of sound-making devices for children. And she's like, no, you said you were going to do this, you're going to do this. And I was like, okay. I got to think of a way to get rid of the cables in a way that is like modular, that can end up on the floor, that can hurt kids. And I want a lot of people to play it. So I started playing with this really old technology called capacitive sweeping, which I actually read about in a Disney paper. And it allows me to tell if people are able to like hold a thing and then touch a person, which person they're touching and when, which actually really changes the interaction from something like the bare conductive board with the touch tree. Because it's not just one person touching a thing. It's one person touching a thing and then another person or a different person. So you get this really nice interaction. So I developed this system that allows as many people as I've been able to throw at it. I've had players, about 20 people is as many people as you can collaboratively fit in a giant circle. But this is what the system looks like. You can put people between it. And I developed games based on this idea of touching other people that you do not know, which was kind of ridiculous. So I watched kids kind of think about the system for quite a long time and try and figure out how to use it. And from there, I designed a bunch of interactivity. So I'll play a video of what the very first build of the system looked like. It's all sound-based, so if you can't hear the sound, there's like no reason. Yeah, if you try and press buttons, you'll hear, it'll cue you to interact, so try and press a button.
Let's connect.
And then if you two connect, you'll get a sound. So this was the very first, right? So all the different boxes will do different things when people touch each other. Okay, so giant groups of people. I kept iterating the system, and then I decided to develop game mechanics for it. So I got kids playing it, and what was really interesting is they were absolutely amazed that the system would know they touched another person. And I know that sounds really subtle, but think about it. Like, when do we touch other people with our technology? So I ended up taking it to the GDC, which was kind of a surprise. And I showed it there, and I played it with a couple thousand people, which was kind of fun. Some people made fan art, which was great. And it kind of looks like this when people play it. But I have a video that I thought I'd show you guys of a massive circle of people playing it. So they have to touch each other when the boxes light up. They're trying to work out how to get around the circle to do just that. So it's saying yep when they succeed. So that's basically what the game ended up looking like. And I'm going to continue thinking about how to do this, but up until now I've been trying to figure out like how to make my systems more and more and more robust. Well, now I think I'm going to flip it around and try and think, how do I make them less permanent? How do I make them for destruction? Because children are monsters, and they will destroy any installation you give them. And I figure the best thing you can do is actually just redistribute all that labor to the children. So make them build it. So I'm going to make a version now which is kit-based, and kids can build themselves. And I'm playing around with paper, and that's going really well. So this is my game. It'll be out on Kickstarter fairly soon. You'll be able to buy it for your kids, which will be ridiculous, and they will be able to build robots. So it's called Bot Party. Cool. Awesome. That's it. I'm Phoenix Ferry. Bye.